Okay, the following is a video over 0.9 notes, and this is square roots and simplifying radicals. I'm going to be pretty basic on this because our necessity for simplifying radicals we don't need to go into that much algebra, but I do want to talk about something that we call perfect squares. Okay, perfect squares. These are important numbers that we need to know. Okay, so, the thing about square root is that we get them by squaring numbers. Okay, they work hand in hand. So if I take, say, 1 squared, that's doing 1 times 1, and that gives me 1. Okay, that's pretty basic. 1's perfect square. Let's take 2 squared. Okay, that's saying it's me taking 2 times 2, which gives me 4. Okay, 3 squared, which gives me 3 times 3, which gives me 9. 4 squared is 4 times 4, which gives me 16. 5 squared is 5 times 5, which gives me 25. Okay, 6 squared, which is 6 times 6, which gives me 36. 7 squared is 7 times 7, which is 49. 8 squared, which is 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. 10 squared is 10 times 10, which is 100. 11 squared is 11 times 11, which is 121. 12 squared, which is 12 times 12, which is 144. 13 squared is 13 times 13, which is 169. 14 squared is 14 times 14, which gives me 196. And then 15 squared is 15 times 15. Oh, what is that? Let's do that one real quick. I can never remember. I'm pretty sure it's 225. So 15 squared. Yeah, 225. Okay. So all of these numbers are perfect squares. Okay. These are the numbers that I'm looking for that will help me simplify my radicals. Okay. So these are the perfect squares that I will need to use. Okay. These are the numbers that are perfect squares. Okay. So now let's talk about a square root. Okay. Now a square root, okay, when I square a number and multiply it by itself and see what I get. A square root is the opposite of squaring a number. Okay, we're going backwards of squaring a number. Okay, so if I take the square root of 1, I'm going to get 1. Okay, if I take the square root of 4, I'm going to get 2. If I take the square root of 9, I get 3. If I take the square root of 16, I get 4. The square root of 25, and I get 5. If I take the square root of 36, I get 6, and so on. Okay, so all of these numbers, if I take the square root of them, I'm back with the base number that I started with. Okay, and these are the numbers that I'm concerned with. These are the numbers that I want to look for. Okay, so let's take a look at an example. Let's look at example 1. I'm not going to go through the other examples. We can go through the other examples, but this is very, very heavy on the algebra 2. And for our purposes in this class, we're not really going to need it. Okay. So what I want to do is I want to simplify the square root of 45. Okay. Now, my method of doing this is I want to split this into the product of 2 radicals. And under one of those radicals needs to be a perfect square. So let's go back to our list real quick. Which one of these numbers can I divide into 45? And the answer is 9. Okay, so I'm going to go back here and I'm going to say, okay, I can split up 45 into the product of 9 and 5. Those 2 numbers multiplied together will give me 45. And this is a product, this is something that a property of radicals that you can do. And the reason why I chose the square root of 9 is because I can take the square root of that. Okay, that becomes 3 times the square root of 5. Now, I cannot take the square root of 5. If I did, I would get a decimal, but 5 is not one of my perfect square numbers, okay? So I leave my answer like this. This is in simplified form, okay? And we want to be able to do that. You guys can all get to this point. Getting to this point's a little bit tricky, okay? Now, let's take a look at part B. Part B is the square root of 6 times the square root of 15, and we want to simplify that. Well, okay, so 6 and 15 they're not perfect squares, okay, so I can't readily take the square root of these numbers. But the square root of 6, are there any perfect squares that divide into 6? Well, I know that 1 is 1, okay, 4 and 9, okay, it doesn't have any. All right, let's look at the square root of 15. Does that have anything? Okay, 4 doesn't divide into it, neither does 9, so that doesn't work. Okay, so but what I am doing is I am multiplying these two together. So if I multiply these two together, 6 times 15 actually gives me 90. So I get the square root of 90, okay? If I'm multiplying radicals, I just multiply the numbers underneath and I keep the radical simple, okay? Now I have this number 90. Now the question is, do I have any perfect squares that I can divide into 90? And the answer is 9 again, okay? So watch what I do here. I'm going to split this up, and I'm going to write this as the product of the square root of 9 times the square root of 10. Okay, and when I do that, the square root of 9 is 3 times the square root of 10. Okay, and so 3 times the square root of 10, this is a number, okay? Square root of 10, I am unable to simplify that. There are 4 and 9 do not divide into 10, so that doesn't work, so that's all I'm left with. But the idea here, guys, is to split these numbers up into the product of two numbers, and one of those numbers needs to be a perfect square. And then you can simplify it from there. You may think that you may do it one way. You may have to repeat this process until you get it completely simplified, okay? But that's all I've got for right now. This is something that we will be doing all year long, okay? So rule of thumb, split these numbers up into the product of two numbers. One of them needs to be a perfect square. So these numbers here, guys, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. These are numbers that we need to identify as perfect squares and use them when we are simplifying radicals. Okay, that's all I got. I hope you enjoyed this video. I had a lot of fun making it.